first problem. Find the orthogonal transformation which transforms the quadratic form x1 square plus 3x2 square plus 3x3 square minus 2x2 x3 to canonical form. Means we are converting that quadratic form to canonical form. Canonical form means sum of the squares form, another name of the canonical form. Now given quadratic form q equal to x1 square plus 3x2 square plus 3x3 square minus 2x2 x3. Now observe from the already I explained quadratic form logic. Square terms you write in place of principal diagonal. Coefficients of square terms. Coefficient of x1 square is 1. Coefficient of x2 square is 3. Coefficient of x3 square is 3. In place of principal diagonal, I am writing 1, 1, 1, 3, 3. 2x2, x3 is available, means x1, x2 is not available and x1, x3 is also not available. Now position of 1, 1 means x1 square. 1, 1 is coming, that's why x1 into x1 is x1 square. Next element, position of next element, first row, second column, 1, 2 is there, x1, x2. What is the coefficient of x1, x2? It is not available, 0. Means 0, 0 immediately. In the first row you write 0. In the first column also immediately you write 0. Next, position of the next element. First row, third column. First row, third column x1, x3. First row x1. Third column x3, like that. You have to understand. x1, x3. x1, x3 is also not available. In place of the coefficient of x1, x3 is I am taking as 0. 0 I am writing here. Immediately you write in the first column is also 0. In the first row you are writing 0. Immediately you write in the first column 0. The position of the next element. Second row first column means x2 x1. Already I wrote there. Position of the next element. Second row second column x2 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 square. I wrote there 3. Coefficient of x2 square. Coefficient of the position of the next element is second row third column x2 x3. Coefficient of x2 x3 is half of that one. Minus 1, minus 1. Immediately in the second row you write minus 1. In the second column also you write minus 1. Anyhow, the position of the last element is third row, third column. x3, x3 is there. x3 square. Coefficient of x3 square is 3. I wrote there 3. Like this we will construct the real symmetric matrix from the given quadratic form. Now if you want to convert quadratic form to canonical form, first step is construct the real symmetric matrix. Second step, find the eigenvalues and eigenvectors of the matrix. Already we did how to calculate the eigenvalues and eigenvectors of the matrix. Now consider the characteristic equation is determinant of A minus lambda I equal to 0. Characteristic equation of A is 1 minus lambda, 0, 0, 0, 3 minus lambda, minus 1, 0, minus 1, 3 minus lambda equal to 0. Characteristic equation by using formula lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. C1 equal to sum of the principal diagonal elements. 1, 3, 3 are the principal diagonal elements. 1 plus 3 equal to 7. C2 equal to minor of 1 plus minor of 3 plus minor of 3 means C2 equals to sum of the minors of principal diagonal elements. C2 equal to minor of 1, determinant of 3 minus 1 3 plus minor of 3 1 0 0 3 plus minor of 3, determinant of 1 0 0 3. After calculation 8 plus 3 plus 3 equal to 14. C3 equal to determinant of A 8. By using calculator it will give the determinant of A. You enter that matrix in scientific calculator. Now while substituting all these things C1, C2, C3, the characteristic equation becomes as lambda cube minus 7 lambda square plus 14 lambda minus 8 equal to 0. That implies lambda equal to 1, 2, 4 are the eigenvalues of A, capital matrix A. Now let x1 equal to here 3 are different eigenvalues, then you calculate the eigenvectors by cross multiplication method. Let x1 equal to x1, x2, x3 which is not equal to 0 be the eigenvector corresponding to eigenvalue lambda equal to 1 such that a minus lambda I into x1 equal to 0. Now I am writing the system. A minus lambda I into x1 equal to 0, 1 minus lambda, 0, 0, 0, 3 minus lambda, minus 1, 0, minus 1, 3 minus lambda into vector x1, x2, x3 equal to 0, 0, 0. Now here I am substituting lambda equal to 1, then it becomes 0, 0, 0, 0, 2, minus 1, 0, minus 1, 2 into vector x1, x2, x3, 0, 0, 0. Now on multiplying these two matrices, we are getting the equations 2x2 minus x3 equal to 0 minus x2 plus 2x3 equal to 0. On solving x2 equal to 0, x3 equal to 0. Then x1 is missing here. There is no chance to get x1. Directly I am constructing the equation x1 equal to some parameter k. Therefore x1 equal to k 0 0, k is common, 1 0 0 is linearly independent vector. First eigenvector x1 equal to 1 0 0 is the eigenvector corresponding to lambda equal to 1. Similarly, in the same way you can calculate x2 and x3. I am writing here directly. Already we did this process in eigenvalues and eigenvectors. x2 equal to 0, 1, 1 and 0, minus 1, 1 are the eigenvectors corresponding to lambda equal to 2 and 4 respectively. Now x1, x2, x3 are pairwise orthogonal vectors. Now observe this one. Already I explained you, if the given matrix is symmetric matrix means first row, first column elements are same, second row, second column elements are same, third row and third column elements are same, then that matrix is called symmetric matrix. If it is like that, then you have to calculate normalized modal matrix. Instead of modal matrix, we are calculating normalized modal matrix. That normalized modal matrix P cap equal to x1 by norm x1, x2 by norm x2, x3 by norm x3. Norm x1 under root 1 square plus 0 square plus 0 square is 1. Similarly, norm x2 equal to root 2 and norm x3 equal to root 2. Now I am constructing P cap. First row 1 0 0 0 1 by root 2 minus 1 by root 2 0 1 by root 2 plus 1 by root 2. Now we have to do diagonalization procedure here. Means we have to show that P cap transpose A into P cap. If it is modal matrix, we are constructing P inverse into A into P. This is normalized modal matrix. That's why you should construct P cap transpose A into P cap. Now I am writing here P cap transpose A into P cap equal to P cap transpose means row elements, you write row elements as column elements. First row write as first column, means interchange the rows and columns in the first matrix. Next A matrix 1 0 0 0 3 minus 1 0 minus 1 3 and P cap. Now you enter these three matrices in your calculator. On multiplication we get 1 0 0 0 2 0 0 0 4 which is nothing but diagonal matrix whose diagonal elements are the eigenvalues of A. Now orthogonal transformation Y transpose D into Y is called orthogonal transformation. Y transpose where Y equal to Y1, Y2, Y3. This is column vector. Now Y transpose means row wise I am writing here Y1, Y2, Y3 and matrix A and column matrix Y1, Y2, Y3. On multiplication Y1 square plus 2Y2 square plus 4Y3 square which is canonical form.